So in this module, we're going to describe yet another way that we can increase muscle force production from our muscles. And that is called the stretch shortening cycle, the SSC. So some people equate that with a counter movement. Some people equate it with storage of energy in tendons. Some people equate it with muscle spindles and Golgi tendon organs. But there are many hypotheses about why the stretch shortening cycle or this counter movement does increase muscle force production, and we're going to cover all four of those hypotheses. So the first hypothesis of the stretch shortening cycle, where you do a counter movement, and in this image you see you're stretching your gastrocnemius before you shorten it into a concentric contraction. And the first hypothesis is that we're storing energy in the PEC and the SEC. Remember, the PECs are all your mesiums: endomesium, paramecium, epimecium, and your SECs are your tendon. And in this particular case, your Achilles tendon is huge, so it can store a lot of energy. So the second hypothesis for why with a stretch shortening cycle we can increase muscle force production has to do with eccentric contractions followed by concentric contractions. So, and they equate that to a stimulation of the muscle spindle. And we'll get into the muscle spindle in the next slide. But this graph below shows that if you only do a concentric contraction, the amount of force that you get in blue. If you have an eccentric contraction preceding that concentric contraction, you have a 40 to 50% increase in muscle force production from that concentric contraction. And now the third one shows an eccentric followed by a concentric, but with no force increase because the timing between the contractions, between the eccentric and concentric, was too long to take advantage of that muscle spindle reflex. So let's summarize what a muscle spindle is and what a Golgi tendon organ is. And those are the two neural pathways, that reflex pathways that we'll discuss in the course. The muscle spindle is parallel to the muscle fibers, like a little mini muscle within those muscle fibers. It monitors muscle length. And if it's stimulated, it wants to reduce the stretch in a muscle. So if you overstretch a muscle, that muscle spindle will fire and say, whoa, I don't want to rip this muscle apart, so I'm going to do everything in my power to shorten that muscle. And that's as opposed to the Golgi tendon organ, which is in series with the muscle fiber. Right? So it's down at the tendon, and it monitors muscle tension and force. And it says if you're trying to generate so much force out of that muscle that it's pulling on that tendon, it does not want to rupture either the muscle or the tendon, so it will relieve the tension or the force in that muscle and basically shut the muscle off. All right, so let's look at the reflex or the stretch reflex from the muscle spindle that is hypothesized to increase that concentric contraction. So this is the sequence. The muscle length provides the stimulus, right? So you've taken your hamstring and you've kicked a soccer ball and you put that hamstring muscle in a lengthened position that stimulates the muscle spindle. And here's the response. There's an excitation of the stretched muscle fibers, so that hamstring fires to try to shorten that muscle. There's an excitation of any synergist muscles, so say the other hamstring muscles, maybe the gastrocnemius to flex the knee to shorten that hamstring muscle. There's an inhibition of the antagonist muscles, right? So all the muscles that are trying to lengthen your hamstring muscle or say extend the knee and flex the hip are shut off. And so this reflex is taken advantage through back swings, right? This eccentric stretching followed by the foreswing, a crouch before a vertical jump, and the backswing in a golf swing as well. These are all trying to take advantage of that excitation of the muscle and the synergist muscles to increase that torque production of that joint. So this is a really nice image that we're going to see again for stimulation of the Golgi tendon organ. But I think it's a good comparison, so I'm going to walk you through it. So on the left side is the muscle spindle, and if you can see, the muscle is attached to two rods, and the muscle spindle is right next to it. On the right side, the Golgi tendon organ has a muscle that's going to be stretched, and the Golgi tendon organ is in the tendon. So you can see where the little record button is. So in this case, the stimulus is a stretch, right? So they stretch both the muscle spindle setup and the Golgi tendon organ setup. So they separate those rods. And then you look at the afferent activity, and that's the sensory output from the muscle spindle and the GTO. So you can see on the muscle spindle side, from a stretch, from an increase in muscle length, there's a huge afferent activity, right? So that stimulated that muscle spindle response. If you look at the GTO, there's much less afferent activity from that muscle length stretch. So there's some, but that's not the primary stimulus of the Golgi tendon organ. So let's look at what is the primary stimulation of the Golgi tendon organ. So if you have an increase in muscle force, there's an increase in tendon stretch. That will stimulate the GTOs, or the Golgi tendon organ, and the response or the reflex is to inhibit that muscle contraction, right? Because it's saying you are generating so much force, something's going to rupture, we're going to turn you off. And it's a protective mechanism during, say, lifting. Right? If somebody's lifting something too heavy and they drop it, it's because their muscles just said, forget it. Hopefully that occurs before they rip a muscle or rupture a tendon. Now, your GTO threshold will develop as you learn a new skill. Because if you think about it, if your GTO threshold was constant, you could never get stronger, right? Because you would always be stimulating that GTO and shutting off that muscle. So as you train, your GTO threshold will move with you as you learn the new skill. So here's the same image. On the left is the muscle or spindle setup, and on the right is a GTO spindle. So now the stimulus is not a length change, but they're stimulating the muscle so it shortens or contracts, right? So you can see the left side contracts, and what happens to that muscle spindle? It becomes slack. So if you look at the afferent activity, it is very low. But on the other side, when you stimulate that muscle and contract that muscle, you're actually stretching the Golgi tendon organ. And if you look at the afferent activity on the Golgi tendon organ side, it's much higher. So muscle stimulation is the stimulus to the GTO. Muscle length changes are the stimulus for the muscle spindle. So there are two other hypotheses that are given when people want to describe why this stretch shortening cycle or this counter movement can increase force production of a muscle. The third one is that you have these slack fibers before you initiate a movement, and when you do this counter movement, you kind of stretch them out and align the cross bridges. And if you remember, the number of cross bridges formed, then the increase in force production. And the final hypothesis of why the stretch shortening cycle works is some people believe that since the slow twitch fibers take longer to develop tension, that this counter movement provides that time to engage these slow twitch fibers. Whether these last two play a huge role in it, aside from the muscle spindle reflex and the storage of energy, remains to be seen, but these are all hypotheses that are given to explain the stretch shortening cycle mechanism.